Good morning. We're still on acids, and I'm going to teach the pH scale. Okay, and there's logarithms crop up into this. I will give a class on logarithms, but you guys do not have to know it. You just have to know how to use your calculator for it. Watch. Press the calculator on. Let's say the log of 10. Press N10, it's going to be 1. Press log, and you get 1. Let's use 100. Press log, it's going to be 2, right? Press 1000, 1, 2, 3. What is it going to be? 3. Oh, I didn't do that right. 1000, 1, 1, 2, 3. Press log, and we get 3. So the log of 1,000,000 is going to be 6, but that is to the base 10. If it was to the base 2, it would be different. I'll talk about that as a separate class. You guys only need to know how to use your calculator to solve pH problems. But I'll cover even more difficult ones than you need to know about. Now this was on the board before because I was going to give a different talk. I'll just go over these things. Common strong acids. Hydrochloric, hydroiodic, hydrofluoric. Hydrofluoric is a funny one. Hydrochloric acid you get in your stomach but only in diluted form. Hydrofluoric acid, you can't keep it anywhere. Right? You can't put it into glass, it goes right through it. So if you want a frost glass, put your name on it, you can use hydrofluoric acid. So why do you keep it? Lots of other ways. Sulfuric, phosphoric, nitric. So these have a hydrogen plus a halogen. These have a hydrogen plus a radical, sulfate, phosphate, nitric. This should be HNO3, sorry. Nitric acid, very dangerous. I used to do all sorts of crazy things with it when I was a kid. Now, bases. These guys all have a H. These guys all have an OH. And it's no coincidence that H plus OH gives H2O, which is going to be at a pH 7 or neutral. So, sodium hydroxide, potassium hydroxide. These are single valence elements. Calcium hydroxide, magnesium hydroxide. Double valence elements, and acid plus base gives us salt and water. For example, hydrochloric acid plus potassium hydroxide gives potassium chloride and water. That's that. This is supposed to be a pH lesson, and now I go into the lesson. That was just an aside because it happened to be on the board. I didn't want to waste it. So it's coming off, and we're doing pH. Now pH can be quite interesting. You're working with a scale of 1 to 7. 1 to 7 which are acidic, and then 7 to 14 which are basic. But later on in a separate class, I'm going to invent a different scale. I'll use the number 1 to 10. I prefer 10. But chemists use 1 to 14. Now, the pH scale. Stands for the potential of hydrogen, stands for the potential of hydroxyl. In other words, when a solution has an abundance, right, that means more than an abundance of OH, you have a base. And when you have an abundance of hydrogen, you have what? An abundance of hydrogen is going to be an acid. So, and it goes from 0 to 7, which are acid, and then base. I'm actually going to go over all of it, but I just remind you of a couple of things. That's what those things are. Now, 10 to the power minus 1 is 1/10 or 0.01. That's a pattern that I just want you to get used to. Now the log of 1 is 0. And the log of 10 to the power of 6 to the base 10 is 6. Log of 10. These are logs, but you don't need to know it if you can use your calculator. Let's scan that now and just go straight into the definition of pH. Now this is the number of moles per liter or the concentration of H plus ions in solution. If you know this, you can plug into this formula. Let's do one. Suppose that the concentration of hydrogen positive ions in solution is 0.04. Now when you have a decimal, you're going to get a negative log, okay? Anything less than 1 is a negative logarithm, so we have a sign here to make sure that our answer is going to be positive. So for that we'll use our calculator. I actually happen to know what it is, but you guys don't. So I go 0.04 in the calculator, I can't see it, and press log. What comes up? Minus negative 0.139 whatever, I'll round it off, 0.14 with a negative sign. Now negative times a negative is a positive. So this stuff is an acid. And they're all like that. There's no difference. Now for POH, you're given the same thing. Suppose that we're given that the concentration of OH in a solution is 0.006. Then the exact same thing applies. You press in 0.006 on your calculator. And there's where's the calculator? And we go log, and up comes negative 2.22. Negative times negative is a positive. Now don't forget that this is a POH and not H, so it's a base. It's opposite, okay? Now we have a very important formula, because I'm going to do some examples. If you need the POH, you could find the pH and vice versa. if we're given POH is 2, then pH is 14 minus 2, which is 12, which is a base. Let's do one differently. Think of a different example. Now, when I talk about logs, I'll talk about this thing later on. But if we're given the pH, we can find the H, in other words, the concentration. So if we're given that the pH is 2, what is the molarity of H in the solution? Well, it's going to be 10 to the power of minus 2. Well, that is the answer. 10 to the power of minus 2, but we can write it as 1 over 10 squared, or 1/100th, or 0.01. Similarly, you could go find the concentration if you're given the actual OH, if you're given the POH, you can find the molarity of OH. Let's go through the whole scale for fun. So you see how trivial this stuff is. There are no more examples other than the ones I've shown you. Now, my son gave me a very nice note. Sean, everything is on that little nice page of handwriting that you gave me, and I don't think that's your handwriting. It looks like a girl's. It's too good to be yours. It's too good to be a guy's. It looks like a girl's handwriting, but that's fine. She wrote it up very neatly, whoever she is. I'm going to go through the whole scale. Suppose we're given the molarity to be 10 to the power minus 1, which is 0.1. Then we go so now the log of a negative number, it's a fraction, so the log of 0.1 is 1. I just happen to know that. Now this is a very useful symbol. It means that implies. This implies that this is true. You use that in mathematics. If you have an equation going here, that line implies that, and the last line is always called QED. The last line, which was to be shown. So that's pH 2. Now I don't have to go through it all now because it's the same pattern. Watch this. The log of anything, if you go over the next decimal place, it just goes up by 1 factor. So, concentration is 0.001, 0.0001, 0.0001, 0.0000, I forget, and that's the way it works. pH 1, 2, 3, 4, 5, 6, 7, and then you become neutral. So these are all the bases. When you go over 0.7, pH is 8, 9, 10, 11, 12, 13, 14. That's the whole scale. Now let's see what pOH is. Well, it's 14 minus this. Uh, 14 minus 5 is 9. Do I have to go through all of that? What's the pOH here? 14 minus 8, yeah? All the way down. See how easy it is, right? Dead simple. Remember, pH, you just subtract for the OH if you know to get the OH, and vice versa. Is there anything worth doing on this? Okay, now that we have done this, that's your pH. I will do a little bit of logs. How about that? Extra. Now you just have to use your calculators to do logs, but it's also useful to know what the hell they are. Now I've been using the base 10, okay? Let's do a different base. I'll use the base 2. Well, the general idea is this. That's the base and that's the exponent. So log 2 to the base 2 is 0. Oh no, sorry. Okay. Log 2 to the base 2 is 1. Log 4 to the base 2 is 2 because 2 squared is 4. That's the way it works. 2 cubed is 8, so the log of 2 to the base 2 is 3. 2 cubed is 8. 2 to the power 4, 2 to the power 4 is 16. 2 to the power 5 is 32. 32, 64, 128, 256, 512, 1024, 2048, 4096. They're the powers of 2, right? You could figure it out. That's enough. I'll do a whole class on logs one day. You guys are masters of pH if you just follow through the examples I gave you. Now don't forget, that's when you're given the molarity. If you're given a mass, I showed you in the previous class how to find the molarity. So you might have to do that problem in 2 steps. 1, to find the molarity using the mass. 2, to find the concentration. I'm not big on the chemistry. Okay, so go back and look at the class that I gave you on moles. All right, that's enough of that one.